just to set the stage, to give context, suppose you have a data set and you have a pipeline that's making predictions on your data as it comes in. One corrupted example in that data set, depending on how many you have, might not make a dent in the overall performance. But if there are enough corrupted examples, then you might see a performance drop. So the goal really is to identify when enough examples are corrupted. And why is this hard? This is hard because not all corruptions might be imported. They might not actually impact downstream accuracy, as we saw in the previous notebook. And also, we might not have access to feature importances or other things that might tell us, what features are more meaningful than others in our pipeline. So we want to broadly alert if we think there's a corruption or an error in the data. And alerting too much, which causes fatigue, especially if the alerts aren't actually correct corruptions. So our two goals. One is to alert precisely, which means every alert that we send out actually corresponds to an error or corruption. And the other one is we want to alert with high recall. So what that means is, of all the alerts that we send out, those are covering most of the actual errors. So a very, very dumb strategy that has, trivially perfect precision is sending no alerts or maybe sending one alert that was correct because, 100% of those alerts were spot on the money. But it has terrible recall, right? Because we're not actually capturing all of the errors in our data set. So this is really hard to do, to assess that trade-off between precision and recall and to have a data validation adapt to that.